Welcome to our channel Quaint Cosmos. Today we are going to dive into a fascinating topic, fascinating phenomenon, Hall effect. Yes, we are talking about Hall effect and its use in the field of magnetic field sensing. Yes, this is the requirement. Actually, this has become indispensable in many industries, whether it is healthcare, whether it is aerospace, whether it is automotive industries. In many fields, the use of magnetic field sensing has become indispensable. And for this purpose, the Hall effect, this phenomenon, no doubt this is a fascinating phenomenon. This phenomenon is used. Okay, so this effect is known as Hall effect. This was discovered by Edwin Hall. What is that effect? So, to explain that effect, one arrangement is required, that is, magnets are required and current carrying conductor or semiconductor. Both carries current. Okay, both carry current, that is known to you. So, a conductor or a semiconductor is required and say electromagnets or permanent magnets are required. Okay, so there is a magnetic field and you have placed a current carrying conductor through which current is carrying. Current is flowing or drifting. Means electrons are drifting through the conductor and that means current is flowing through the conductor. So in that case, what happens? If it is placed perpendicularly to the magnetic field, then in that case the charged particles inside the conductor or the semiconductor experience a sideways force, and this generates a voltage known as Hall voltage or Hall potential difference. Most interestingly, this Hall voltage or the Hall potential difference is proportional to magnetic field strength. Yes, no doubt this is interesting because just by measuring the Hall voltage, you can easily say the amount of magnetic field strength. That means if there is an unknown magnetic field, so the strength of that magnetic field can easily be known by using this phenomenon Hall effect. For that purpose, a simple arrangement you need to make. A current carrying conductor or semiconductor you have to take and you have to supply voltage or current to that conductor, and by measuring the generated or the produced voltage you can easily detect the strength of the magnetic field. So in compass, in the manufacturing of compass, this is used in speedometers of cars or bikes. Okay, you know speedometers are there which displays the speed of that vehicle. Okay, so in those cases moving parts are there, and with moving parts magnets are attached. So with the speed of the car, the magnetic field strength changes, and that is detected by using this Hall effect, and accordingly speed can be measured. So actually Hall effect measures the magnetic field strength, and accordingly it can say you or tell you about other parameters which are linked with the magnetic field strength, or the parameters upon which magnetic field strength depends. So parameters are changing, means unknown parameters are changing, accordingly magnetic field strength is changing, and that magnetic field strength is being detected by using this Hall effect. So just by knowing the Hall effect we can say many things about those unknown parameters. Okay, so this is the science behind this technology. Yes, no doubt there are various parameters upon which the sensitivity of this magnetic field sensing depends, such as material. Of course, material is a property, means different materials have different properties, such as gallium arsenide, that is better than silicon. Again, indium antimonide, that is also better than silicon. So it's better to use these materials for the purpose of magnetic field sensing. Okay. Again, temperature. Yes, there is an effect of temperature on this. What is the effect? When temperature rises, the sensitivity of the instrument decreases. Okay. So there is an effect of temperature. There is an effect of supply voltage also. If supply voltage is sufficient, in that case it becomes easier to measure the output voltage or the voltage produced by the Hall effect. So it depends upon this input voltage or the supply voltage also. Again, if the magnetic field strength is more, in that case it can be easily sensed by the by using Hall effect. But there is a limit. In case of very high magnetic field strength, in that case you cannot you won't get linear responses. Rather you would get non-linear responses. That means in those cases the generated voltage or the means I am talking about Hall voltage or the Hall potential difference would not be proportional to the magnetic field strength in case of very high magnetic field strengths. So you know, in case of technologies there are so many boundaries, there are so many limitations. Being within the limits, you need to use the instruments. Okay. Before using anything, you should know the limits. Yes, of course, limits are there. So many things are there upon which the sensitivity and the accuracy of the instrument depends. I am talking about magnetic field sensing instruments. The instruments which can measure the magnetic field strength, and everything here is being discussed with reference to Hall effect. There is one more Hall effect, the name of that effect is actually quantized Hall effect. That is another phenomenon. Okay, that is a separate phenomenon that will be discussed in a separate video. Quantized Hall effect and this Hall effect, which I have discussed so far in this video, are different. That quantized Hall effect was discovered by von Klitzing. Okay, Klaus von Klitzing. That was discovered, and that is different. That is used in the field of quantum mechanics. That's why the name is given quantized Hall effect. And here this is different. Okay, this is not the field of quantum mechanics. Okay. Anyway, so this was all about today's topic. Today's topic was what? The phenomenon Hall effect and its use in the field of magnetic field sensing. And this is the requirement in many industries like healthcare, aerospace, automotive industries. So many industries are there where you would find the application of detecting magnetic field strength, and for that purpose the Hall effect is used. Anyway, so this was all about today's topic, and this is the end of this video. Thank you for watching this video.